let's discuss 2h number 2. I can see this quadratic equation. So a is minus. So whatever it is, without looking at, is going to be a maximum. The graph has a maximum. So now let's fix the data to this type of graph. Now for this graph, uh, in here x is speed and y is fuel consumption. So use question number A, use the model to find to speed at which the car has fuel consumption of 32.5. Okay, so this is x-axis, this is y-axis, and when x equals 0, y is 16. It means the graph go something like this. This is 0, 16. So 32.5. So fuel consumption is y is 32.5. So I'll draw the line y equal 32.5. Then I can see that there are two speeds. This is the speed axis. There are two speeds give the same fuel consumption. So now we need to find those two speeds. Finding those two means we are finding those two intersection point. We know how to find the intersection point. We have to solve these two equations, quadratic and this linear equation. And actually we need x value. I'll put x1 and x2. Those two are the values. So we'll work out now. 32.5 equal minus 0.1 x square, 0.975x plus 16. So 0.01 x square minus 0.975x plus 32.5 minus 16 equal 0. So 0.01 square minus 0.975x, 32 take away 16, 32 and add another 5, 16.5 equal 0. X is minus b minus 0.975 plus or minus b square 0.01 square minus 4 times a 0 and 16.5 divided by 2 times 0.01. When you simplify this one, you can see that there are two answers. X is 21.8 and 75.7. So this is 21.8 and this is 75.7. So those are the two answers. Now we want to turn this equation into this form. So y equals 0.01 x squared 0.975x plus 16. So from here I'll take minus 0.01 So x square plus minus 97.5 uh, x plus 16, so 0.01, x minus 97.5 half is 48.75 square minus 48.7 square plus 16, so minus 0.01 times x minus 48.75 plus 0.01 times 48.75 square plus 16, 0.01 times x minus 47.75 square, this is plus 39.765. So I'll bring to this form. The plus value is here 39.765, then minus 0.01 times x minus 48.75 square. Now A is 39.765, B is 0.01, and C is 48.75. From here we know that x minus 48.75 equals 0, x equals 48.75. So the maximum coordinate of x coordinate of the maximum point is 48.75, and y is 39.765. 39.765. So question C, the greatest efficiency, you can see that when x equal 48.75, x value 48.75. RD, use the model to calculate the fuel consumption of car traveling at 120 mph. So is this model is valid for x equal 120? Actually, we can see by looking at the graph, uh, those are the two roads, and this is not acceptable as x can't be negative. So this is the road. We can clearly say that after this uh, speed, the fuel consumption going to be negative. So so it is not right, because fuel consumption can't be negative. We can see this all negative values. So by looking at the graph, we can see that after one x value, beyond that, so this model is not valid basically. They are talking about especially x equal 120, so we won't talk about 120. So we'll sub this value to here and we'll work out y equal 39.675, 0.01, 120 minus 48.75 square. We will get as answer as minus 11, yes. So 120 is somewhere here, because y value is going to be a negative value, minus 11. So you can tell that this model is not valid for very high speed or something like that. You can write the conclusion. So you can write fuel consumption cannot be negative, hence the model is not valid for very high speeds. Let's discuss question number 3. Uh, GF. Okay, G. Um, so when I see this one, this is also a value is negative. This is so this is a quadratic equation. It has a maximum. So F is number of kilogram fertilizers and G is the yield. Do you think this graph is going to be match? When we put more fertilizers, the yield is going to be increase and it will maximize, and if we put more fertilizers, the yield is becoming less, uh, reducing, and maybe it go down as well. And we know that in this point, if we put up to this much, the plants will die. So you can't think about yielding. And do you think that if there is no fertilizer, when the fertilizer is 0, this is f-axis, this is g-axis, um, still there is a yield? Yes. Usually, if there is no fertilizer, still there is a yield. We'll check whether it is right or wrong. When f equals 0, there should be some value. Okay, when I put f equals 0 here, I can see g is 6. It means it's going to be start from 6. So this is 0, 6. Even I can see by looking at this graph, after some point this graph is not valid after this root. Okay, now let's look at it about the questions. Question we already done. According to the model, how much grain would you each hectare yield without any fertilizers? Yes, when f equals 0, g is 6 plus 0 minus 0, g is 6. So yield is 6 tons. Part B, farmer currently use 20 kilograms fertilizers per hectare. How much more fertilizers would we need to use to increase his grain yield by 1 ton per hectare? So he's using 20 kg, 20. Then we can find the yield he will get. Then we will add 1 more ton, and then we will get the relevant x. So when f is 20, g is 0 plus 0.03 times 20 plus 0.1234 and 6 times 20 square. Let me calculate. So the answer is 6.5576. So you want to increase by 1. So then it's going to be 7.576. Then we want to find that value. Now G is 7.576. Now we have to solve this equation for G equals 7.576. So G equals this one. So we are going to solve I sub instead of G this one. Then I will take everything to other side. 0.0006 square minus 0.03f plus 7.576 minus 6 equals 0 plus 1.576 plus 0 x equal a equal 0.0006 b minus 0.03 and c equal 1.76 x equal minus b plus or minus b square minus 4 times um, 3 4 times 1.76 over 2 times 0.0004006. So the answer should be F. So F equal, let me calculate, 59.6 or F equal 440.4. So this is 59.6 or the same consumption value 440.4. We don't need to get this answer because it's extreme. It's more costing, so we have to work from left to right. So this is the lowest cost. So what is the difference then? Difference is 59.6 minus 20, which is 0.9. 39.6. We need extra to get to increase the yield by 1 ton per hectare. Please read question number 4. We have this equation T equal M minus 1000 P. T equal number of tickets sold. M is a constant. P is a price. To find this model, we have to find this constant. Then they should give T and P to work out this constant. Then I am ready to get the T. T is 10,000 and which price 30. So I'll sub that value to here. 10,000 equal M minus 1000 times 10. So M equal 10,000 plus 30,000, which is going to be 40,000. Now we have the model T equal 40,000 minus 1000 P. Now there is the equation for revenue I equal P times M minus 1 to 3,000 P. We know that P times 40,000 minus 1000 P. So we want to rearrange this equation. I can see R equal minus 1000 P square plus 40,000 P. So I'll take minus 10,000 out. So P square plus 40 minus 40P. So minus 1000 P20 minus 220 square 400, then minus 1000 P20 square plus again it will become another 400,000. So minus 10,000 1020 square. So this is going to be A minus B A C square A is 400,000, B is 1,000, and C is 20. And P equals 0, R equals 0. Okay, this kind of graph. Um, this is ticket price 10, and that is 10,000, and this is revenue. Oh, number 6. So this is 300,000, which is 30 times 10,000, and we found out. Now we want to know the maximum point. So p minus 20 equals 0, p equals 20. So x, this is 20, goal is 20, 400,000. So this will show you that if you increase ticket price to 10 to 20, your income will be 400,000.